All right, we're back. We're working on finishing up this problem. So we've used our little substitution trick here to find A and D, but we're not sure how to find B and C. Well, what we want to do here is we want to use the fact that we know A is 2 and D is 2 to substitute those values in and work from that. So our new equation we are going to put that 2 in for the A. We don't know what B is yet, so we're going to leave that. We don't know what C is, so we're going to leave that. And we know D is 2. All right. Oops, wrong button, sorry. Okay, so now what? Well, what we're going to do is we're actually going to multiply this out. And we're going to see what happens when we do that. It'll work out quite well if we're able to notice something. So I'm going to multiply out this whole thing. I'm going to multiply that out. This is going to be kind of algebraically intensive. That's okay. So what I'm going to do is I'm just going to pause the video because you guys don't need to watch me do all this. I'll write this in. I'll start the video again. All right, so what I did is I cubed the x minus 2. Okay, maybe using my cubing pattern that I know. If not, you have to take x minus 2 times x minus 2, do all that out. I squared the x minus 2, so I still have the x plus 1 yet to do, but there's the x minus 2 squared. I multiplied out x plus 1 times x minus 2, and I distribute the 2 there. Okay. What I'm going to do next now is I'm going to distribute this 2 in there. I'm going to multiply x plus 1 times x squared minus 4x plus 4. I'm going to distribute the c. Okay. Now, feel free to pause to write this down. I'm going to pause my video. I'm going to do my next step of multiplying. All right, so what I did now is I distributed the 2 there. I multiplied the x plus 1 times the x squared minus 4x plus 4. That gave me this. Then I just combined like terms, which kind of reduced it down in size, which was nice. I distributed my c like that. So my next step is now I'm going to distribute my b to that term. Again, I'll pause my video. All right, so I've distributed that b now to each of those terms. And again, if you want to pause the video to catch up on your writing, you're welcome to do that, but I'm going to continue on now. I shouldn't need to pause it anymore during this video. Okay, so what I want to do now is, just as if there weren't that b and c there, if we were simplifying this, the next thing we do is we'd combine like terms. So here's how we're going to do that. Well, we'd start with the x cubes, right? How many x cubes terms do I have? I've got 2x cubed there. I've got bx cubed right there. Those are the only x cubed terms that I have. So how many x cubed terms do I have? I have 2 plus b x cubed terms. Okay. So notice, again, 2x cubed, bx cubed gives me 2 plus b x cubed. Now let's go on to the x squared terms. Let's see, I have a negative 12, I have a negative 3b, and I have a c. So we have a total of negative 12 minus 3b plus c x squareds. Again, boom, 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 gives me that many x squareds. Now we would go on to the x's. 24, negative c, and 2. So 24 and the negative, 24 and the 2 would be 26. So we have 26 minus c x's. Last thing we've got, let's see here. Let's underline that in orange as we color code. What color am I up to? I guess we'll go black. Is our constant term, negative 8, 4b, negative 2c, and 2. gives me, well, the negative 8 and the 2 gives me a negative 6. And then we have 4b, and we have minus 2c. And that's our constant term. Okay. Now take a moment and look at the equation that we have. Look at the left side. Look at the right side. How is the left side organized? X cubes, x squareds, x's, constants. How's our right side organized? X cubes, x squareds, x's, constants. So what do we know from this? Well, here's what we know. We know we have 3x cubes, and that has to be equal to the number of x cubes on this side. And how many x cubes do we have on this side? 2 plus b. So we know 3 has to equal 2 plus b. I think we just found b. Now, let's go to the x squareds. Well, there's negative 18x squareds on the left side. That has to equal the number of x squareds on the right side. So negative 18 has to equal negative 12 minus 3b plus c. Now, we know what b is. So let's substitute in b. And I think we can find c. Let's see, that'd be what, minus 15 plus c. So c is negative 3. And we found all 4 of our constant. Find out we actually didn't need to do these two. You could have, I just went right in order with the x squareds. You could have noticed that 29, I wrote 26. 29 x's has to equal 26 minus 3, or it's minus c x's. We could have just used the x term and we still would have got c as negative 3. So that works pretty well. So our first technique that we like when we're trying to solve for our unknowns is substitute a value of x in that will cancel out everything but one of your unknowns. After that, we've got to do a lot of multiplying, but then we can combine like terms and say the coefficients must be equal. So where does this put us? Okay. What was our original? This was our original right here. Let's see if I can't copy. Actually, I don't think I can copy that. My recorder's blocking it. What we'll do is we'll take a picture. This is equal to the integral of, well, what did we have? A over x plus 1. A is 2. That's 2 over x plus 1. Plus b over x minus 2. b we got was 1. So 1 over x minus 2 plus c over x minus 2 squared. And for c we got negative 3. And then we had our x minus cubed, or x minus 2. I did the same thing on earlier. X minus 2 cubed was our d, and our d was 2. All right. So now let's integrate. What is the integral of 2 over x plus 1? 2 natural log the absolute value of x plus 1 plus integral of 1 over x minus 2 natural log of the absolute value of x minus 2 plus, how do we do this with that x minus 2 squared? Well, if you're unsure, you can always just write it like this for now. Like that. And then how about this one? We have that cube down there, so let's just write that as 2 times the integral of 1 over x minus 2 cubed dx. So now you have to ask yourself, okay, how would we do this? And my first reaction, and I've talked about this a little bit already, but we're going to talk about it more as these different techniques pile up and we practice, is that let's start with a simpler technique first, and let's see if that simpler technique produces what we want. So when I look at this one, I know my simplest technique when I have a function inside of another, I have a composite function, is a simple U substitution. So let's let u equal x minus 2, and let's see if this works out. Du dx would then equal just 1. So dx would just be equal to du. So this becomes, again, this is for this one, 1 over u squared times dx, which is just du. And can we find that? Well, this is just the same as the integral of u to the negative second du, which is equal to, let's see, add 1 to the exponent. I need a negative in front to cancel that out. So we end up with negative 1 over u to the first, and u is x minus 2. That's what this one is. Let's do the same thing here. Let's see here. Let's let u equal x minus 2 again. Du dx equals 1, so dx equals du. So this is the integral of 1 over u cubed du, which is the same as u to the negative third, which is the same as u to the, let's add 1, let's put a negative 1/2 in front, so I get negative 1 over 2 x minus 2 squared. All right, so let's wrap this thing up. This is equal to 2 natural log absolute value of x plus 1 plus natural log of the absolute value of x minus 2 minus 3, and then what was this integral again? That was negative 1 over x minus 2. So I'm actually going to write this as the negatives become positive, 3 over x minus 2 plus 2 times, what was that one? Let's see here, where did I go? There we go, negative 1 over 2x minus 2 squared. So I'm going to change this to be a minus 2 over 2x minus 2 squared. Is that right? Yep. The 2's then cancel. We have that plus c. And there we go. Okay, it took a long time. That's okay. We're persevered. We did it. That's our integral.